Today we will solve a numerical based on the psychometric chart where we have the values of a condition of a air, outer air, and the air is passing through the coil, and we have to calculate the condition of a air after the coil. So that is the basic numerical which we will solve today using the psychometric chart. So here we have taken one problem statement. The problem statement is the outside air is at 31 degrees Celsius dry bulb temperature and 18.5 degrees Celsius wet bulb temperature, enters a cooling coil at the rate of 40 meter cube per minute, and the effective surface temperature of the coil is 4.5 degrees Celsius. The effective surface temperature is also called as a ADP. We know that ADP is a apparatus dew point temperature, which is for cooling coil, is given as 4.5 degrees Celsius, and its cooling capacity is 12.5 kilowatt of refrigeration. We have to find here dry bulb and wet bulb temperature of the air leaving the coil, enthalpy of air leaving the coil, and the bypass factor of the coil. So here given values are outer condition of air, which is 31 degrees Celsius dBT and 18.5 degrees Celsius WBT, and airflow we have volumetric flow rate, which is 40 meter cube per minute, and coil ADP given as 4.5 degrees Celsius, and cooling capacity is 12.5 kilowatt. We have to find the dBT of air leaving the coil, enthalpy of air leaving the coil, and bypass factor. So we will start with the numerical. Here we are having one psychometric chart. So initially we have to draw the condition of a air which is given to us. So that is a, let's suppose, point 1, which is at outer condition. We have 31 degrees Celsius dBT and 18.5 degrees Celsius WBT. We have drawn this point on a chart and connected it to the ADP of a coil, which is given as 4.5 degrees Celsius. ADP we can find on the saturation line here, and dBT is 31 degrees Celsius for point 1, and this cross line shows the WBT. We have connected into 18.5, so we will get point number 1 and ADP of a coil at saturation line. So after the drawing 2 points, we have to find some basic values for the point 1. So here we can draw this line parallel to the enthalpy lines at the passing through the point 1, so that we can get the enthalpy at a point 1, which is around 53 kilojoule per kg of dry air. And after the drawing line, 1 minute, this is the line parallel to the specific volume lines. Here we can see the specific volume lines in this chart. Values are given below: 0.8, 0.85, 0.9 respectively. And after passing through the this point, if we extend the line here, so we will get value between the 0.85 and 0.9. So we can take 0.875 meter cube per dry air. So this is our specific volume for air outside the coil. So after the getting the values of enthalpy, we have one formula, which is the heat transfer through the coil. Q is equals to mcp delta T. mcp delta T is nothing but enthalpy. So here we have Q into mass flow rate into enthalpy change. H1 is the enthalpy at a outer condition of air, and H2 is a enthalpy of air after leaving the coil. So here we have to find the plus mass flow rate. So we have volumetric flow rate and specific volume. So we can easily calculate the mass flow rate, which is comes around 45.7 kg per minute. We convert it into kg per second, which is 0.7619 kg per second. So after the getting the mass flow rate, we can, and we are having the enthalpy H1, and we also having the Q, which is given as a 12.5 kilowatt cooling capacity of a coil. So we can calculate the value of a H2. So after the substituting the values, we get the H2 as 36.59 kilojoule per kg, so which is nothing but enthalpy of air leaving the coil. So we got the one property, enthalpy of air leaving the coil. We can draw this line passing through this line which is from 1 to ADP. So where the point meets, that is nothing but our point number 2. So point number 2 we get on the line on the basis of S2 which we got from a calculation. So in the chart we can draw one vertical line uh, which meets the uh, bottom line which is a dBT, dry bulb temperature. After the connecting we get dBT as 18.8 degrees Celsius, and this line shows the WBT. So WBT we get 17.7 degrees Celsius around. So these are nothing but condition of air after the passing through coil, cooling coil. So from the psychrometric chart, we get the condition of air leaving the coil as 18.8 degrees Celsius WBT, sorry, 18.88 degrees Celsius DBT, dry bulb temperature, and 17.7 degrees Celsius WBT. So next part is a bypass factor. So we have the formula for bypass factor as TD2 minus ADP upon TD1 minus ADP. So TD2 is nothing but temperature of dry bulb temperature of air after the cooling coil, and TD1 is a dry bulb temperature of a coil before the cooling. And we have TD1 value in given in a numerical, and TD2 value we have calculated from psychrometric chart, which is 18.8 degrees Celsius dBT. So after putting in formula, we get bypass factor as 0.5396. So these are the this is the simple numerical which we can solve using the psychrometric chart. If we are having the one condition which is, let's suppose, air entering the coil or air leaving the coil, so we can use the and passing through the cooling coil. So using the psychrometric chart we can find the condition of air after the coil or before the coil, or vice versa, if corresponding values are given for any one condition, so we can find for the other using this chart. So we get the values after the calculation and from the psychrometric chart as final answer as dBT and WBT of air leaving the coil as 18.8 degrees Celsius dBT and 17.7 degrees Celsius WBT. Enthalpy of air leaving the coil as 36.6 kilojoule per kg, and bypass factor as 0.5396. This was the numerical.